There is a place in the Pacific Ocean known as Point Nemo, and it's not named that because Nemo lives there. In fact, no one does. No ships pass, no islands break the horizon. It's the farthest point on Earth from any landmass, located thousands of kilometers from the nearest coastline. To put that into perspective, astronauts aboard the International Space Station are often closer to humanity than anything floating on the surface here. Because of this isolation, Point Nemo is also known as the spacecraft graveyard. When satellites and space stations reach the end of their lifespan, they are deorbited and guided towards this region, a place chosen not for safety but for its emptiness. Sometimes the ocean looks like it's glitching. Waves move in two directions at once, forming near-perfect squares across the surface. This phenomenon is called a cross-sea, or more commonly, square waves. They occur when two distant storms create separate wave systems, which then collide at nearly right angles. The result is a surface that looks calm, structured, even artificial. I mean, it does look like bad rendering in a video game. But beneath is danger in chaos. The intersecting wave energy creates unpredictable multidirectional currents. Vessels can be caught between competing forces, tossed side to side without time to adjust course. Swimmers and divers face even greater risk. The turbulence below the surface can disorient them, drag them under, or push them into deeper, colder water. Most icebergs are easy to spot, bright, white, and drifting quietly across the sea like floating mountains. But not all icebergs are like that. Some are dark. These are black icebergs, and they're exactly as ominous as they sound. These icebergs are formed in two ways. Some are made of ancient glacial ice compressed over centuries. This kind of ice contains very little air, making it dense and clear, so dense in fact that it absorbs almost all the light that hits it. When viewed from the right angle, it appears black. Others become black through surface staining, collecting volcanic ash as they break off from glaciers, like a snowball rolling through a coal mine. The result is a floating mass that reflects almost no light, and at night it becomes practically invisible. All life on Earth depends on the sun. That's what we thought anyway. Then we discovered chemosynthesis, a way of producing energy without sunlight, using chemical reactions instead of light. It takes place in harsh, hidden environments far below the surface where sunlight never reaches and oxygen runs out. The most dramatic example is found around hydrothermal vents, which are cracks in the seafloor that release heat, minerals, and toxic gases. Located a few thousand meters below the surface, there is no sunlight down there. Also, the water can reach over 400 degrees Celsius, hot enough to melt lead. And yet, life thrives. Bacteria uses chemosynthesis to convert hydrogen sulfide and methane into sugars. Tube worms, shrimp, and clams live off those bacteria. Entire ecosystems survive this way, completely independent of sunlight. Chemosynthesis is believed to be one of the earliest forms of metabolism on Earth, possibly paving the way for respiration and photosynthesis. And because it doesn't rely on the sun, some scientists believe this kind of life could be the last to survive. Long after the sun dies in a merely few billion years, chemosynthetic organisms might still remain for a few billion years longer. The ocean is home to millions of species, some more bizarre than others, and many have yet to be discovered. But every now and then the camera catches a glimpse on some of them. For instance, this is a rare sighting of the giant oarfish, the longest bony fish in the world, often referred to as the doomsday fish or the earthquake fish. They're rumored to surface before or after an earthquake. Or this footage of the whale shark, the largest known living fish and the largest non-mammalian vertebrate on the planet. Their average length can reach up to 12 meters. Or the swimming feather star, also known as a crinoid. This group of animals first appeared over 480 million years ago, making them one of the ocean's oldest survivors. Or this footage of this cute pufferfish. It looks like a lake, but it's already underwater. These are called brine pools, rare, dense pockets of salt water that collected on the ocean floor. They form when salt from deep underground mixes with water, making it much heavier than the seawater around it. Instead of blending in, the brine sinks and settles into low spots, creating a kind of underwater lake with its own surface, shorelines, and even waves. But it's not a safe place. Brine pools are full of toxic chemicals like methane and hydrogen sulfide. They contain little or no oxygen. Most marine animals that enter don't come back. And yet, even though we've discovered places like this, the ocean remains mostly unexplored. So, what else is out there? Immense, ancient, restless. The ocean. It spans more than 2/3 of our planet, shaping weather, cradling life, and bearing secrets beneath kilometers of water. And yet, we've barely seen it. I mean, really, we've mapped the entire surface of Mars, a planet over 50 million kilometers away, yet here on Earth, we've mapped just 26% of the ocean floor. And to make it even more interesting, we've only truly explored less than 5% of the entire ocean. Which naturally leads to one unavoidable question: why? And the answer is simple: money. Ocean exploration is expensive. It requires ships, fuel, deep diving equipment, and teams trained to operate in hostile, high-pressure environments. A single expedition can cost millions. And unlike space missions, ocean research doesn't attract headlines. It doesn't promise colonization, tourism, or alien contact. So it remains underfunded, overlooked, quietly drifting to the bottom of every budget. It's funny, we dream of distant worlds, yet we've barely begun to understand our own.